Hello everyone, I am your friend Shadab Imam and currently we are dealing with the topic of game theory under operations research. And today we are going to learn a new method which is called graphical method to solve the problem. So please watch this video till the end, and if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. Before moving on to the problem, we must understand that when we need to apply the graphical method. So graphical method is generally used when we do not find a saddle point and we are also unable to reduce the matrix by dominance rule. And there is one condition with graphical method, that our matrix has to be of 2 cross n or m cross 2 matrix. That means our matrix has to be 2 cross n or m cross 2 matrix. This means any one of the player must have only 2 strategies to play, then only we will be able to apply the graphical method. Now let us move on to the problem, and the problem says that solve the following 2 cross 4 game by graphical method. Here this is the payoff matrix for player A, where player A has 2 strategies A1 and A2, whereas player B has 4 strategies B1, B2, B3, B4. Now as I have said that we will use this graphical method when we do not able to find the saddle point and we are also unable to reduce the matrix by dominance rule. But here in this problem we can see that we can reduce this matrix. So it is easily to understand that if we compare column B1, which has the values as 3 and 5, and if we compare the average of column B3 and B4, so average will be 4 plus 0, 4 by 2, that means 2. Here the average of these two will be 7 plus 3, 10, 10 by 2 is 5. So this will be 2, this will be 5 if we consider the average values. If we consider the average values, so this is B3 plus B4 by 2. And this is equal to 2, this is equal to 5. And now if we compare B1 with the average of B3 and B4, we can see that 2 is less than 3 and 5 is equal to 5. So from here we can say that the combination of strategies B3 and B4 will together dominate the strategy B1, because B's objective is to minimize the loss. So whenever we are comparing columns, we will select the values which are less than or equal to the other values or the values of other column. So here we can see that this is 2, this is 3, so this is lesser, this is 5, this is 5, both are equal. That means strategy B1 is dominated by the combination of strategy B3 and B4. Now even after knowing this, we are going to solve it as it is by using graphical method and see what will happen if we use this strategy also. So I am erasing this, and now we are going to solve this 2 cross 4 matrix by graphical method. In order to solve this problem, we need to consider the player with 2 strategies only. And now in this, if we consider that player A plays strategy A1 P time, that means the probability of player A playing strategy A1 is P, and we know that player A is playing only 2 strategies A1 and A2. So if player A plays P% of time strategy A1, then he will play strategy A2 1 minus P% of time. So the probability of player A playing strategy A1 is P, whereas the probability of player A playing strategy A2 is 1 minus P. Now after this, what we need to do is we will find the expected payoff for player A, or we can say that expected payoff for the player which is having 2 strategies. So we are going to calculate the expected payoff for player A for each strategy of B. That means for taking B1 as the pure strategy, for taking B2 as the pure strategy, and so on. So now we are going to draw a table and find out the A's expected payoff whenever we are paying a pure strategy for player B. So let us draw the table here. Now this is the table we need to draw here. So the first column is B's pure strategy. So we know that B has 4 strategies: B1, B2, B3 and B4. So we will write here B1, B2, B3 and B4. Now we need to find out the A's expected payoff for these pure strategies. Suppose for strategy B1, A's payoff will be A will play P percentage of time A1 and 1 minus P percent of time A2. So A's payoff will be 3P plus 5 into 1 minus P. So A's payoff will be 3P plus 5 into 1 minus P. 5, 1 minus P. Now if we simplify this will be 3P plus 5 minus of 5P. So minus 5P plus 3P is minus 2P. So this will be 5 minus 2P. Similarly, we will find A's payoff for pure strategies B2, B3 and B4 also. So let us do this. For B2, the A's payoff will be 3P plus 4 times 1 minus P. So this is 3P plus 4 times of 1 minus P, and this is equal to 4 minus of P. Now let us move on to the third strategy, B3. So this is 4P plus 3 times of 1 minus P. So this is 3 times of 1 minus P, and this is equal to 3 plus P. Now moving on to B4. So this is 0P plus 7 times 1 minus P, and this is equal to 7 minus 7P. Now after calculating this, we need to find out the value of expected payoff when the probability is 0 and 100%. So for the value where probability is taken as 0, we will have this value 5 minus 2 multiplied by 0. So this is equal to 5. So this is 5. Similarly 4 minus 0 is 4. Similarly 3 plus 0 is 3, and 7 minus 7 into 0 is 7. In a similar manner, we will calculate the value of A's expected payoff when the probability is 100% or 1. So here 5 minus 2 into 1. So 5 minus 2 is 3. So this is 3. Now this is 4 minus 1 is 3. So this is again 3. Here 3 plus 1 is 4. Here 7 minus of 7 into 1. 7 minus 7 is 0. So now we have calculated these values, and we can check that these values are exactly similar to those given in the problem. So this is 3340 5437. So we can check this from here, and now let us draw the graph. So this is the graph we need to draw here, and we can see that in x-axis we have probabilities from 0 to 1, and in y-axis we have values from 1 to 10 on both the sides at p equal to 0 and at p equal to 1. We can also have the negative values in the y-axis, but here in our problem we are having only positive values, so that's why I have only drawn the upper half. But if the negative value exists here, we can draw the negative values in the y-axis and join the graph. Now let us move ahead. For strategy B1, A's payoff for p equal to 0 is 5. So here this point will be 5, and then for p equal to 1 the point is 3. So here the point is 3. Now we need to join these 2 points. So here we have drawn this 5 and 3. Now this represents that this payoff is for pure strategy B1. So we will write B1 somewhere here. Now let us see for pure strategy B2. At p equal to 0 point is 4. So here this is at p equal to 0 the point is 4, and at p is equals to 1 the point is at 3. So here point is at 3. Now again we need to join these 2 points. So here we have joined these 2 points, and this represents the pure strategy B2. So we will write B2 somewhere here. And now let us draw the line for pure strategy B3. So at p is equals to 0 we have 3. So this is 3, and at p is equals to 1 we have value 4. So at p is equals to 1 we have value 4. So let us join these 2 points. Now we have joined these 2 points, and this represents the pure strategy B3. So we will write B3 somewhere here. This is B3. Now for B4 we will see that at p is equals to 0 the point is 7. So at p is equals to 0 the point is 7. Here it is. And at p is equals to 1 the point is 0. So at p is equals to 1 the point is somewhere here. Now let us join these 2. So we have joined these 2 points, and now this represents the pure strategy B4. So we will write B4. Let us write B4 here. Now what we'll do is, we can see that we have found out the expected payoff for player A, and the objective of player A is to maximize the profit. Now in order to maximize the profit, what we will do is we will find the lower bound region first. So let us see what is the lower bound region here, and this region shows the lower bound region. So this is the lower bound region, and among this region we will find the maximum point. So we can see here that the maximum point is coming somewhere here, and let us name this point X. So this is point X, and this point is called maxi-min point. So this is our maxi-min point, and this is the lower bound region. Now I am saying this again, please remember this, that as we have found out the expected payoff for player A, and player A's objective is to maximize the profit. So player A will try to maximize the minimum possible gain, and in order to do that, player A will find a maxi-min value. Now in order to find this maxi-min value, we will select the lower bound region. So this is our lower bound region, and we will select the maximum point in this lower bound region. So this is the maximum point, and this point we have taken as X, and this is our maxi-min point. Now what generally happens is, at the maxi-min or minimax point, generally only 2 strategies crossed out, and we can easily form a 2x2 matrix using that 2 strategies. Now here in this problem we can see that at maxi-min point there are 3 strategies which are crossing each other: strategy B2, strategy B3 and B4. Now in this particular case, what we will do is we will select any 2 strategies with opposite slope. Remember this, whenever there are more than 2 strategies passing through this maxi-min point or minimax point, what we will do is we will select any 2 strategy having the opposite slope. So here let us select this B3 and B4 first. So let us select this B3 and B4 and draw a 2x2 matrix. So here we have drawn the 2x2 matrix. where player A has two strategies A1 and A2, and for player B we have selected strategies B3 and B4, which are intersecting at this maximum point and are having opposite slopes. So now by mixed strategies we know that we need to calculate oddments here, and oddments is nothing but the difference in rows and columns. So for row 1 the difference is 4 minus 0, and we will write this difference against the opposite row. So this is 4 and we have write 4 here. Similarly this is 7 minus 3 is 4, so we will write 4 against the opposite row. The difference in column 1 is 4 minus 3 1, and 1 we will write here against the opposite column. Similarly here 7 minus 0 is 7, and 7 we will write against the opposite column. Now we can see here that the sum of oddments vertically and horizontally are same, so this is coming as 8, and we can say that once this is same, the value of game for player A and player B are equal. Now from here we can say that the probability of player A playing strategy, let this be P, we have already taken it, which is equal to 4 divided by 4 plus 4. So this is 4 divided by 8, or we can say 1 by 2. And this strategy A2 is given as 1 minus P, which is equals to 1 minus 1 by 2, and it will come as 1 by 2. So the probability of player A playing strategy A1 is 1 by 2, or 50% of time, and probability of player A playing strategy A2 is 1 by 2, or 50% of time. Similarly we will find out the probabilities of player B playing strategy B3 and B4. So let Q3 be the strategy of player B playing strategy B3. So this is equal to 7 divided by 7 plus 1, 8. Similarly, probability of player B playing strategy B4 is Q4, and this is equal to 1 divided by 7 plus 1. So 1 divided by 7 plus 1 is 8. Now this is the probability of time player B will play strategy B3 and B4 respectively. Now let us calculate the value of game here. So the value of game is given as, we'll take any row or any one of columns. So I am taking row 1. This is 4 multiplied by corresponding probability. So this is 4 multiplied by 7 by 8 plus 0 multiplied by 1 by 8, 0 multiplied by 1 by 8. So this will come as, this is 1, 2 times, this is 7 by 2, or we can say 3 and a half, 3, 1 by 2. So the value of game for player A and player B both are coming as 3, 1 by 2. And the optimal strategies for player A, the optimal strategy can be given as 1 by 2 and 1 by 2. That means player A will play strategy A1 and A2 50% of time. Now the optimal strategy for player B, this can be given as 0, 0, 7 by 8 and 1 by 8. So here we can see that here we do not have strategy B1 and B2. So B1 and B2 has 0 probability. That means player B will not play strategy B1 and B2, and it will play strategy B3 7 by 8 times and strategy B4 1 by 8 times. Now we have solved this problem. Now what happens if we do not consider these two strategies? Suppose if we consider some other strategies which are having opposite slope. So we can see that here among these three strategies which are intersecting at X, so among B3, B2 and B4, we can see that B4 and B2 are having the same slope. That means we can either choose B4 or B2, and previously we have taken B4. Now let us try to solve by taking these two strategies, that is B3 and B2. Now let us solve this again. Now let us try to solve this taking strategy B2 and B3. As we can see that B2 and B3 are having opposite slope. B3 is having this slope and B2 is having this slope, and they are intersecting at X. So now we have taken the two strategies as B2 and B3, and to find the solution we need to find the oddments here. So the difference here is 4 minus 3, 1, and we'll write 1 against the opposite row. Similarly for row 2 the difference is 1, and 1 we will write against the opposite row. In column also the difference is 1, so 1 will write here, this is 1, 1 will write here, and as we can see that the sum of vertical and horizontal oddments are equal, the value of game will be equal. Now let us find the probability. So probability of player A playing A1 is P, which is equals to 1 divided by 1 plus 1, so this is 1 by 2. Similarly the probability of player P playing strategy A2 is 1 minus P, we have already mentioned it there. So this is 1 minus 1 by 2, which is equal to 1 by 2. Now let us move to player B and let us take the probability of player B playing strategy B2 is Q2, which is equal to 1 divided by 1 plus 1. So this is 1 by 2. Similarly, the probability of player B playing strategy B3 is Q3, which is equal to 1 divided by 1 plus 1. So this is 1 by 2. Now we can see that from here we can say that player A will play strategy A1 and A2 1 by 2 times or 50% of time. Similarly player B will play strategy B3 and B2 1 by 2 times, or we can say 50 and 50% of time. Now let us find the value of game, and in order to find the value of game let us select any one row or column. So as usual I am selecting row 1. So this value multiply by this corresponding probability, this value multiply by this corresponding probability. So this will come as 3 into 1 by 2 plus 4 into 1 by 2, which is equals to, this is 3 by 2, this is 4 by 2, 3 plus 2 7, this is 7 by 2, which is equals to 3 1 by 2. Now from here we can see that in the previous matrix also the value of game is 3.5, and here also the value of game is 3.5. So we can say that after taking these two strategies also we are getting the same solution. That means there is an alternate optima, or we can say there is a multiple solution or more than one solution exists for this particular solution. Now let us write the optimal strategies for player A and player B, and for player A optimal strategies for A1 and A2 are 1 by 2 and 1 by 2. Similarly for player B optimal strategies are 0, 1 by 2, 1 by 2 and 0. Now here we can see that for player B strategy B1 is not here, so it will play B1 0% of time. Strategy B2 is 1 by 2 times, strategy B3 is 1 by 2 times, and strategy B4 is not here, so it will not play strategy B2. Now let us consider one more point. Earlier in this question we have said that although this matrix can be reduced by dominance, then also we are eager to take strategy B1 and solve this by graphical method. Now what effect does B1 have? So in this graphical method we can see that strategy B1 is from 3 to 5, or we can say that from 5 to 3, and this strategy line of B1 does not interfering with the feasible region here. So we can say that this strategy B1 is known as the redundant strategy. That means it does not contribute to the feasible region or to the maximum or minimax value. So whenever we are going to take any such strategy which can be dominated, then it is of no use, because this strategy will be a redundant strategy and it will not participate in this feasible region. Now after analyzing this problem, we came to the conclusion that the problem where we have more than two strategies intersecting each other at maximum point or minimax point, we will have the alternate optimal solution. So we can have more than one solution at this particular situation. So I hope this is clear to you. If you like this lecture, please share the lecture. Have a nice day. Thank you very much.